Imagine a world overloaded with gears, steam, and brass, where clockwork butterflies flutter against copper clouds and phantom whistles echo through foggy cobblestone streets. Long before silicon chips, AI, and electric servos, ingenious minds were building machines that seemed alive. These weren't just toys or clocks. They were mechanical specters that walked, wrote, sang, and breathed illusion itself, powered by springs, cams, and sheer audacity. They were called automatons, eerie, wondrous clockwork creations that blurred the line between life and machine in ways that would make any steampunk dreamscape feel tame. Right here, on History of Simple Things. If you've ever stared at a mechanical clock, watched a toy bird flap its wings, or been baffled by a machine that writes or plays music on its own, you've already bumped into the spirit of automatons. At their core, an automaton is simply a mechanical object that operates on its own once set in motion, usually following a predetermined pattern of movements. They are machines that act of their own will, at least in appearance, and for centuries, people treated them with wonder, superstition, and a kind of awe that we now reserve for blockbuster tech demos. The word itself comes from the ancient Greek automatos, meaning self-moving or self-acting, a force of motion without visible strings or hands guiding it. This is important because for most of human history, movement like this was either the realm of living beings or the unexplained forces of the gods. A machine that moved itself, even predictably and mechanically, seemed almost magical. So what made an automaton work? Think of clockwork gears, springs, weights, cams, and levers. These mechanical components store and release energy in coordinated ways so that once the mechanism is triggered, it performs a sequence of actions: walking, turning, writing, playing an instrument, with no further input needed. In that sense, the automaton is a pre-computer robot. It obeys a set of instructions encoded in its mechanics rather than in software. Long before the Industrial Revolution, and long before robotics became a field of study, people were inventing devices that echoed these ideas. Some of the earliest records of mechanical figures date back to ancient civilizations. In ancient Greece, engineers created hydraulic organs and toy theaters, where figures moved by water pressure and simple mechanical tricks. These weren't toys in the modern sense. They were marvels of engineering, the closest thing to automated entertainment in their age. The Roman engineer Vitruvius described early clocks with figures that moved when water flowed or weights dropped, hinting at the first automaton clocks. Later designs, many centuries ahead of their time, continued the theme of mechanics that mimicked life. Over in China and across East Asia, craftsmen built wooden figures powered by water and hidden mechanisms. Some could walk, others performed repetitive tasks at festivals and court celebrations. These weren't just novelties, they were part of a wider tradition of mechanical ingenuity. Many ancient myths and stories also feature automaton-like creations, from man-made statues that move to sentinels of bronze. These tales reveal a deep psychological curiosity. Humanity has always looked at movement and agency and wondered how to replicate it. Fast forward to the Renaissance, a period of renewed interest in art, science, and invention. This is where the study of automatons becomes deliberate rather than accidental. Leonardo da Vinci, the quintessential Renaissance thinker, didn't just draw flying machines and war contraptions. He sketched what modern historians now call Leonardo's robot, a humanoid figure made of gears and pulleys, capable of sitting, standing, turning its head, and moving its arms. These designs weren't theory alone. Researchers have built working reconstructions based on his notes. In this era, automatons became symbols of human mastery over nature, complex objects that demonstrated not only artistic skill, but also mechanical understanding. They challenged viewers to rethink the line between the animate and the inanimate. By the 17th and 18th centuries, automatons had become spectacles. Clockmakers, inventors, and entertainers showcased mechanical marvels that could pour wine without anyone touching the glass, play musical instruments, dance, gesture, or enact tiny scenes with multiple figures. One famous example is Maillard's automaton, built around 1800. This machine could draw pictures and even write text thanks to a system of cams, brass discs that controlled the motion of its mechanical arm. People at the time could hardly believe this machine child could do what seemed to be creative tasks. Another curious chapter in automaton history involves chess-playing machines like El Ajedrecista, which actually played a simple chess endgame without hidden players, using mechanical and electromechanical logic under the board. This approach foreshadowed the transition from purely mechanical to programmable automatic systems. However, not every so-called automaton was what it seemed. The Mechanical Turk, a famed 18th century chess-playing machine, was later revealed to have a human chess player hidden inside its cabinet. These hoaxes, while deceptive, captured public imagination about machines that might rival human skills. So where do automatons fit in the story of robots and computers? Today we think of robots as machines that sense, decide, and act in flexible ways. Automatons don't sense or decide. They follow a fixed mechanical program built into their gears and cams. But they are the great-grandparents of modern robotics and automation. The very concept of a machine that performs tasks without continuous human guidance sets the stage for everything that comes after. In fact, the word robot itself didn't enter common use until the early 20th century, after being introduced in a Czech play in 1920. Before that, most people used automaton or automata to describe self-operating machines. The mechanical logic in automatons also influenced early ideas about computing and automatic control. Machines like the Jacquard loom, which used punch cards to control patterns in fabric, blur the line between simple automation and programmable devices, a direct conceptual link toward modern computers. If you reset your timeline to before the age of microchips, AI, and industrial robots, automatons remind us how curiosity and craftsmanship drove innovation long before electricity or digital computers existed. They show us that humanity's fascination with mimicking life isn't new. Whether built by engineers, artisans, showmen, or dreamers, automatons reflect a deeper desire to understand movement, intention, and ultimately, what it means to create something that seems alive. From the carved figures on old clocks to the interactive installations in modern museums, they continue to inspire wonder. Thank you for watching. If you have suggestions for our next video, feel free to share them in the comments below. We'll be sure to give you an acknowledgement for your contribution. Thank you for joining us on this journey through the history of simple things. Don't forget to like, subscribe, and stay tuned for more stories woven through the smallest details.